Hey guys, my name's Long. I'm a junior at University of Wyoming, majoring in computer science. For my AI project, I did a little experiment with machine learning, specifically reinforcement learning. I built an agent that can play the infamous mobile game Flappy Bird. Well, not perfectly, but much better than an average human player can. And today, I'm so glad to have a chance to share the results with you guys. I hope you guys enjoy it, and let's get started. For those who are unfamiliar with reinforcement learning, on screen is a flowchart representation of its definition. According to scholarpedia.org, reinforcement learning is learning by interacting with an environment. The agent selects its action on basis of its past experiences and also by new choices. You may be wondering, what does that even mean? I'll show you using my project as an example. At the very beginning, our little bird has no idea how to play the game and therefore acts randomly. However, through time, it will eventually improve its behavior. This is achievable by punishing the action sequences that lose the game, as well as giving positive reward for doing the right thing. In my project, every action that loses the game get a punishment of -5 points, while passing each pipe give 1 point. Over time, the bird will learn to avoid states that give negative rewards and focus on states that give positive ones, hence getting better the more time it spends learning. Its actions are no longer random, but in fact, the best option based on its experience. On the screen, you can actually see the bird improving really fast over hundreds of iterations. While I was working on this project, one of the biggest problems I encountered was that, in Flappy Bird, the action space is continuous and infinite. This makes all the conventional data structures such as NumPy matrices unusable, since you can't create a matrix without knowing beforehand its dimension. I solved this problem by putting all the data in a dictionary instead and hand-coded all the operations needed. The second biggest problem was that, just like action space, the state space is also infinite. You can reasonably argue that for every nanosecond, the bird is in a completely different state than it has ever been before. I solved this problem by carefully choosing the parameters that can be made finite, such as difference in y-coordinate. I also rounded up the pixel inputs to the nearest 10, so the algorithm would converge much faster. To wrap things up, I just want to mention that the application for reinforcement learning is huge, even with just basic Q learning like I did in this project. Not only agents can be trained to play single-player games such as Flappy Bird, Mario, they can even play adversarial multiplayer games such as tic-tac-toe, Go, chess, or be practical in real life such as in robotics field. That's it for me today. I hope you enjoyed the presentation. Thanks for watching.